All right, so 3-5. Again, we're talking about equations of parallel and perpendicular. So we looked at the essential question already. So how can we write an equation that's parallel or perpendicular to a line that passes through a point? So first, let's analyze what we know about parallel lines. And we would put same slopes. They have the same slopes. You're going to need to know that for today's problems. Let's box perpendicular. What do we know about perpendicular lines? Is that they have opposite and reciprocal slopes. Okay, so that's going to be key. Opposite and reciprocal. Notice the and, not or. You got to have them both, opposites and reciprocals. So let's look at these really quickly. They're going to ask us to write an equation of the other line. They gave us the equation of one of the lines. They want us to get the equation of the other line. And in letter A, they're saying they're parallel. So let's make the little arrowheads to show that these are parallel. And since they're parallel, we're going to need the same exact slope. So I'm going to need y equals 3/2 x. So y equals 3/2 x because my slope needs to be the same. And then I'm going to need my y-intercept to be a 2, so I'm going to need to put a plus 2 back here. This right here is called your y-intercept. It's where it touches your y-axis. So that is the first one. Now I'm not going to write all that stuff in on all of them, but just to show you how we got that one. Now, as you move to B, that's not parallel because the lines in B intersect. So if they intersect, they can never be parallel. Parallel lines never intersect. So they're telling us that this one is going to be a perpendicular set. So you can put a right angle box in there. And we want to find the equation of this other line right here. So we're going to put y equals, and I need the opposite sign, and I need the reciprocal, negative 2/3 x, and then I need my positive, no, my right here is a negative 1 slope. So this right here is negative 1. And you can see right here my slopes are opposite and reciprocal. Opposite and reciprocal. We changed the sign and we switched it around. So that was B. Let's go to C. Remember, you have the link. If you're needing the link, it's on Classroom. Let's look at C here. So we need to find the equation of this line. These are parallel, so let's put the arrows on them. And we need a same 1/2 slope. So they're going to be the same slope. This one touches down here at negative 3, so minus 3. This negative 3 is how I got that line right there, or that number. So it's a 1/2 x, it's a minus 3. You had the same slope because they're parallel, and you have a new y-intercept where it touches the y-axis. Letter D there, they're intersecting, so they are going to be perpendicular again. So you want to make your right angle box, knowing that those are perpendicular lines. And we want the equation of this line right here, which is going to touch a positive 1. So y equals, opposite of one of the positive would be a negative, and if you reciprocal 1/2, you get a 2. So negative 2x. And then plus 1 because 1 is your y-intercept. This 1 is going to be right here. So there's D. Negative 2x plus 1 is your equation for D. Letter E, again, they don't intersect, so they're going to assume that they're parallel, so we'll put the little arrows on there. And we want to get the equation of this line, y equals, and we're going to use the exact same slope, negative 2x. They had negative 2x, so we got to have negative 2x because the lines are parallel. Our new one touches, oops, we're not doing this one, we're doing this line. Our new line touches at a negative 2. Theirs touched at positive 2, ours touches at negative 2. But it has the exact same slope, negative 2x. And then letter F is going to be perpendicular because they do intersect. So we want to get the equation of this line down here. And we want a positive and we want a 1/2 x. Opposite sign and reciprocal if they're perpendicular. And our line touches down here at minus 2. Minus 2. So that is writing in parallel lines and perpendicular lines. That's all that is. Okay, so we don't have to do the next ones. Same thing. We're not doing anything different. Let's look at this one. Communicate your answer. Let's go ahead and answer the essential question now. How can you write an equation of a line that's parallel or perpendicular to a given line and passes through a given point? You need to do 3 things. You need to find the new slope. It might be the same as the old slope, or it might be the opposite and the reciprocal of the old slope. Okay, so you got to find the new slope first. Secondly, you got to use this formula that we learned when we did the zombie worksheet. Y minus y1 equals m times parentheses x minus x1. Okay, we call that the point slope form. Point slope form is what we call that. It allows us to do our last step, which is solve for y. And that gets us our y equals mx plus b form. And that's what we're looking for, because then we'll know what the slope is and we'll know what the y-intercept is. So that's just the 3 steps you got to take. If you can do those 3 things, you'll be able to find the equation of every line. That's either parallel or perpendicular to another line. So we go down to number 4, and they want us to put this into play. Let's try these 3 steps. So I'm going to draw a line down the middle. We'll do A on this side. We'll do B on this side. It says find the equation of a line parallel in A and perpendicular in B to y equals 3x plus 2. Okay, so here's your slope, 3. That's your m. And then your x1 and your y1 are right here. x1, y1. So our new slope for A, because A is parallel, is going to still be a 3. We're not going to change the slope because it's parallel. So we keep it. So I plug it in, y minus, the y number is negative 2. And then my slope is going to be a 3, and then my x minus, and then my x number is a 1. So we're going to distribute. We'll make these both pluses. So you get y plus 2 equals 3x minus 3. And all you got to do is subtract 2 on both sides. So y equals 3x minus 5. So there is your equation of that line. That's parallel. If you notice, they both have 3x. One has 3x plus 2, so that's going to touch at positive 2. Our new one has 3x minus 5. That's going to touch at negative 5. Let's try perpendicular, though. B is perpendicular. So our new slope, so I'm going to put new perpendicular slope equals, and since positive 3 is my old slope, I need a negative number and I need a reciprocal. So I need a negative and a 1/3. So my new slope is negative 1/3. So let's plug that in. We get y minus, the y number was negative 2 again. Same x and 1, y1. And then my new slope is negative 1/3. X minus my x number is 1. I'm just plugging it into the formula that you see here right above this. The point slope form. Because I know a point, I know a slope. If I plug it in, I can solve for y. So let's make those both plus. So y plus 2. And negative 1/3 x. And then you're going to get a positive 1/3. Negative times negative is positive. If I subtract 2 on both sides, I'm going to subtract 2 on the left, but I'm going to subtract 6/3 on the right. Why do you think I would subtract 6/3? Does that still equal 2? And does it now have a common denominator? Yeah, that way I don't have to worry about common denominators. I have a common denominator now. So I kept it equal to negative 2, but I made it with a common denominator of 3. So those cancel out. My equation is y equals negative 1/3 x. And when you combine those like terms, or those two fractions with common denominators, you're going to get a negative 5/3. So now you have your equation of a line that is perpendicular to our original line, but the y-intercept is going to be negative 5/3, which is negative 1 2/3 if you want to make it improper. You can make it negative 1 2/3. Okay, directed line segment is your only vocab word here. It's moving down a line in a certain direction. Moving on a line in a specific direction. So if they're telling you to go from A to B, you got to start at A and go to B. So you're going in a specific direction. Also, it uses slope. We use slope to get our directed line segments. We can use our slope. So we'll talk about directed line segments when we get to the extra practice, which is just really soon. Just to review slopes of parallel lines, the theorem. If two lines are parallel, that means they have the same slope. You can see M1 equals M2. M is slope. M1 and M2 are the same slopes. So parallel lines have the same slope. Perpendicular lines, they kind of use a different definition. Perpendicular, their product is negative 1. What that means is that they have to be opposite and reciprocal to get a negative 1 product. Okay, so if you multiply them together and it equals negative 1, you know that they were opposites and reciprocals. So, like, take this example. What if we had a 3/2 slope and you change it to a negative and then a 2/3 for the opposite and reciprocal? The positive number times the negative number is going to give you a negative. And then when you cross cancel the 3's, those become 1's. And when you cross cancel the 2's, those become 1's. So 1 times 1 is just 1. So if you multiply two slopes that are opposite and reciprocal, you're going to get negative 1. So that's a good test to see if you actually have perpendicular slopes. Multiply them together, and if your answer is negative 1, you know they were perpendicular. They had to have been perpendicular. All right, let's look at the extra practice. I'm going to come back to 1 and 2. We're going to do the other ones first, because directed line segments are a little bit tricky, and I want to, do those right at the end. So let's look at number 3 first. It says determine which lines are parallel and which lines are perpendicular. To do that, we're going to need their slopes. So we're going to need to find their slopes. So if we go in order, then we need to find the slope of P first. So line P, we need 2 points on P. 2 points on line P. I could use this point up top, and then I could use this next point here, and I go up 1, 2, 3, rise, 1, 2, 3, run. So slope for line P is 3 rise and 3 run, which is just going to be a slope of 1. 3 divided by 3 is 1. That means I could go up 1 and over 1, and I would have this be on that same line. So that's P. Let's go to Q. We need 2 points on Q. So there's a point here, and there's a point down here on Q. 1, 2, 3 up. 1, 2, 3 right. So it also has a rise of 3 and a run of 3, which is also a slope of 1. So what does that tell me about lines P and Q? That they have the exact same slope. They're parallel. P is parallel to Q. So what that means on the graph, I would make little arrowheads on P and on Q because I know now that they're parallel. I proved it because I got their slopes. So I proved it by showing their slopes, so I would make the arrows. And you now know that those two lines are parallel. Let's keep in alphabetical order. Let's find R. Find 2 points on line R. There's one up here, and there's one down here. 1, 2, 3 down, 1, 2, 3, 4 across. 4 to the right. So 3 down is a negative 3, 4 to the right is a positive 4. That is not related at all to a 1. It's not opposite reciprocal. It's not the same. So 1 and P and R, they would just intersect. They wouldn't make any special angles or anything. Let's find S. Line S. We need 2 points on S. Here's a point here. There's a point down here. 1, 2, 3 down. 1, 2, 3 across. So 3 down is negative 3. 3 across is positive 3. So that's a negative 1 slope. That's not the same as a positive 1. Those are not parallel. But what is a 1 and a negative 1? If you multiplied those two numbers together, 1 times negative 1, what would you get? Negative 1, which whenever you multiply two slopes and you get negative 1, they're opposite and they're reciprocal. That means that they're perpendicular. So I'm going to go over here and say P is perpendicular to S. P is perpendicular to S, and Q is perpendicular to S. And I'm going to put right angle boxes up here. Oops, because I know that this is going to be a right angle now. I proved it, and I proved that this is a right angle. Because their slopes are opposites and reciprocals. All right, last one is T. So let's find T's slope. So we got a point on T there. We got another point down there. You're going to go down 1, 2, 3 and over 1, 2, 3, 4. Down 3 and over 4. And so it's going to be parallel to R. So R is parallel to T. So your parallel pairs were P and Q and R and T. Your perpendicular pairs were P and S and Q and S. So that was 3. We had to find parallel slopes and perpendicular slopes. 4 is another good one to review because it says tell whether the lines through the given points. They only give us 2 points. They don't give us a slope. And you might remember this formula. y2 minus y1 over x2 minus x1. Does that one look a little familiar? That's how you find the slope when they give you 2 points. In other words, this top part is your rise. This bottom part is your run. The top part they call the change in the y number. The bottom part they call the change in the x number. But we call it rise over run. So I'm going to go ahead and look at line 1 here. Okay, we'll come down here to line 1. I'm going to do the y number minus the y number. That would be 0 minus 2. And I'm going to put m equals for my slope. So y minus y, 0 minus 2. Then I'm going to do x minus x on the bottom. 2 minus the x is negative 2. It's always a minus, and then the x number was negative. So that means a double negative on the bottom. So my slope is a negative 2 on top and a positive 4 on the bottom. That's a negative 1/2 slope. That's for line 1. line 2, we're going to do my y number minus my y number. That would be negative 2 minus 4. And then my x number would be a 1 minus a 4. So on the bottom, you got 1 minus 4. So on the top, you've got a negative 6. On the bottom, you've got a 3. That is a positive, or a negative, no, it's a negative 3 on the bottom. Negative divided by negative would give me a positive 2 slope. So what do you notice about the two slopes? They're opposite signs, right? And they're reciprocals. So they have to be perpendicular. Opposite and reciprocal slopes. Makes them perpendicular lines. Opposite and reciprocals. So all I had to do there is use my little formula to find the slopes, and I could tell if they were parallel, perpendicular, or neither. Those were perpendicular. Last one is what we did in the communicate, where we made an equation of a line, and they gave us the one line, and they gave us a point. So this is my x1 and my y1 right here. And in this one, I want parallel, so my parallel slope equals 2/3 because it's the same slope. So I'm going to use my equation just like I did before. Y minus the y number is a negative 2. Those are going to be both pluses. The m is a 2/3. X minus the x number is a 3. So you're going to distribute. You get y plus 2 equals 2x, 2/3 x, and then the 3's will cancel. So you're going to get a negative 2 there. And when you subtract 2 on both sides, you'll get y equals 2/3 x minus 4. 2/3 x minus 4. So the 2's canceled out, and you had this as a 1 up here, so you had a 2 times a negative 1 was negative 2. You subtracted 2 on both sides, got a negative 4. Now, it does say they want us to graph, though, so your little ID card might come in handy if you want to draw straight lines. I would use your ID card to do straight lines. Mine aren't going to be that straight, sorry. But I'll draw my original graph first, which was the negative 1 here, and then up 2 and over 3. Up 2 and over 3. And I'm just going to draw that in carefully. That's one line right there. That was the original. And then the line that I came up with is down at 4. And the same slope, up 2 and over 3, up 2 and over 3. And I'll draw that carefully in. And you hopefully see that these two lines you could put arrows on because the two lines are parallel. They have the exact identical slope of 2/3. One touches at negative 1 on the y-axis, the other touches at negative 4 on the y-axis. But they are definitely parallel because they have the exact same slope. Rise 2, run 3. They're both rising 2 and running 3. Rise 2, run 3. The sixth one is we're going to need a perpendicular slope. So perpendicular slope is going to be the opposite sign, negative, and the reciprocal 1/2, negative 1/2. So I'm going to plug it into my equation. Y minus, we have our x1 up here and our y1. So y minus 2, negative 1/2, and then x minus negative 2. Make those plus. And then we're going to distribute. So y minus 2 equals negative 1/2 x. And then the 2's will cancel into 1's. So negative 1 times positive 1 would be a negative 1. And then you just add 2 to both sides. So y equals negative 1/2 x plus 1. That would be your equation for 6. Then we want to graph them both. And again, I would start with the original line. Our original line is y equals 2x plus 3, so I'm going to start at 3 and go up 2 and over 1, and I'm also going to go down 2 into the left 1. Negative negative is also a positive slope. So I'm going to draw that line in there. And then the new line that I came up with starts at a positive 1, and it goes down 1 and over 2. Down 1 and over 2. So that's going to be a line that comes in like this. And if you drew it exactly correct, these would be at right angles right here. That would be perpendicular. They would be exact right angles. And then 6, we did some of those on last notes, on 3-4 notes. How to find the distance from a point to a line. And we talked about it being the perpendicular distance. Perpendicular distance. That's why it comes up in this chapter, because we're talking about perpendicular lines. So first I'd have to graph my equation. So I'm going to start down at negative 5 on the y-axis. And I got to go down 3 and over 1 to the right. So down 3 and over 1 to the right. I could go up 3 if I wanted to, and then I go 1 to the left. That would still be on the same line there. Not a very good line. And then point A is 0, 5. So 1, 2, 3, 4, 5 is right there. We need a perpendicular slope. That would be a positive and a 1/3. So what I need to do is from my point A, go up 1 and over 3. And I could go down 1 and to the left 3. That's going to put me right on the line there. That's the distance that I need. I need the right angle distance. I know my graph's not great because I don't have a graph paper, but that's the distance I need. So it's a right angle. I need this distance up here at the top. That's how far point A, this point right here, is to the line. It's that perpendicular distance away. And the cool thing is, we know how to find distances on a graph. You can just make your little right triangle, which is over 3 and up 1. And then you can just do your Pythagorean theorem. 1 squared plus 3 squared equals c squared. 1 plus 9 is 10. And when you square root it, you get 3.2 units equals c. So it's approximately 3.2 units from A to the line. That's when you measure it at a perpendicular distance. At a distance that makes a right angle to the line. That's the distance you got to measure if you want to find out how far a point is away from a line. All right, that takes us to numbers 1 and 2. Probably just do number 1. Show you how to do it. Okay, so it's telling us that it's a directed line segment A to B. So it's telling us that we need to go from A to B. Okay, so let's draw a quick little x and y axis. Negative 2 and 7. Be right up here at the top. That's point A. Negative 4 and 1 would be point B. And if I connect those two, that's the segment we're talking about. Now, they want the segment to be a 3-to-1 ratio. 3-to-1 ratio. So 3-to-1 ratio, this is point A up here. That means we need to break it into 4 pieces. A 3-to-1 ratio means you got 3 pieces and you got 1 piece. 3 pieces to 1, 3-to-1 ratio. So I need to take that line and break it into 4 equal pieces. So here's how I do it. I use my slope. From A to B, I would go down 1, 2, 3, 4, 5, 6 down, and 1, 2 across. So I would go down 6, and I'd go 2 to the left. Those are 2 negatives. Down is negative, left is negative. But what do 2 negatives give you when you divide? Positive. Is that line a positive slope? Yeah, but we're going from A to B, so we're going in a negative direction. So I had to use my negative numbers. And I need to break this line into 4 pieces. So I'm going to divide by 4 pieces. If I divide by 4, and if I leave it as a decimal, it would be -1.5 and -0.5. -1.5 and -0.5. So I'm going to use that slope on my A to B. So look what I do here. Now watch. From A, I'm going to go down 1.5. Okay, remember it says -1.5. So I'm going to go down 1.5 and over a half, and I'm going to be right on the line right there. If I go down 1.5 and over a half, that puts me right back on the line again right there. If I go down 1.5 and over a half, now I'm on the line there. So I just broke that into 4 equal pieces. Let me show you them. Here's piece number 1, there's piece number 2, there's 3, and there's 4. I got 4 pieces. They want 3 of them on one side and 1 of them on the other. And I got to go from A to B. So I need 3 pieces to 1 piece. That means right here has to be your point P. That's a point that would break a line into 3-to-1 ratio. 3 on one side and 1 on the other. That P is a 3-to-1 ratio. We don't have time to do number 2, but that's how you would. Now, I would try it on your own, and the first thing tomorrow we'll look at it and see if you got it right. But I would try it to see if you can figure it out.